Welcome to this lesson in MCR3U. Today we'll be looking at expanding, simplifying, and factoring polynomials. This should be a review of some grade 10 concepts that you have already looked at. So review of grade 10 concepts. We'll go through a few things in terms of expanding, simplifying, and factoring. So to start, we'll look at expanding and simplifying. So again, expand means to multiply out the brackets, and simplifying means to collect like terms. So here, if we look at expanding and simplifying, we will distribute first. So we'll multiply the 2 into the x plus 1, and we'll multiply this negative 1 into the x into the 4. What that will give us is, once we expand it, we'll get 2x minus 2 minus x minus 4. And here we see that we can combine the x terms. So we can combine the 2x and the negative x, and we can combine the constants, which are negative 2 and negative 4. So here we'll get an answer of x plus 6. Okay, here we have 3x plus 1 squared. The common misconception that some students have is that they just square these two terms here, and they'll write it as 9x squared plus 1. That's incorrect because here the square is on the outside of the bracket, which means that we need to write it out twice. Okay, and if we have to write it out twice, it means that now it's going to be 3x plus 1 multiplied by 3x plus 1. And here, we again multiply 3x by 3x, 3x by 1. The 1 needs to multiply to the 3x and to the 1. So what we'll be left with here is we'll have 9x squared plus 3x plus 3x plus 1. And here we can collect these like terms of 3x and 3x, which gives us the final answer of 9x squared plus 6x plus 1. Okay, so let's move on to factoring, and let's look first at common factoring. So when we're common factoring, we're looking for something that will divide into each of these terms. So in this situation of ax plus ay, we see that we can factor out a common factor of a, and we'll be left with x plus y. So here, if we factor out 3x squared plus 6x, again, you always want to look for a common factor no matter what type of question you're doing. In this situation, we can factor out a common factor of 3x. So it's divisible. So 3x is divisible to 3x squared and to 6x. And we'll be left with 3x bracket x plus 2. Here we have x bracket x plus 3 minus 2 bracket x plus 3. At first thought, some might think of expanding this type of question, but you can see that there's x plus 3 in each of these terms here. So what we can do is we can factor out an x plus 3, and what's left over will be x minus 2. So our final answer is x plus 3, x minus 2. Now let's look at two different types of things here. So we'll look at a difference of squares. And with a difference of squares, we see that x squared minus y squared is equal to x minus y, x plus y. And here with perfect square, if it's x squared, so ax plus b squared is equal to a squared x squared plus 2abx plus b squared. And ax minus b squared is equal to a squared x squared minus 2abx plus b squared. Here, let's look at this first example of x squared minus 81. And so here we can recognize that it's a difference of squares. If we can recognize that it's difference of squares, what you want to do is you want to square root the first term of x squared to give us x, and you can square root the second term of 81 to give us 9. And those are our x and y values that we're going to sub in. Here, remember, it gives us x minus y, x plus y. And so here we have x minus 9, x plus 9 as our final answer. If we look here, of x squared minus 12x plus 36, we can see that this is a perfect square. And we know that it's a perfect square because the first term and the last term can be square rooted. So if we square these, they can be square rooted. And we see that 2 of A and B, A and C equals the B value. So 2AC, which is equal to 2x times 6 is equal to 12x. So there we see that it will become a perfect square. And so because it's a perfect square, we can follow the, the formula that we have with the perfect square, which will give us an answer of x minus 6 squared. Okay, let's look at this next one here. So here we have x minus 2 squared minus 9. And so here again, we also have a difference of squares. If we square root this first term of x minus 2 squared, we'll just be left with x minus 2. And if we square root the second term of 9, we'll be left with 3. So here we'll have x minus 2 minus 3, and we'll have x minus 2 plus 3. And so that can be simplified further into x minus 11. That can be further simplified to x minus 5 and x plus. Okay. Last question here. We have 4x squared plus 28x plus 49. And so again, that's another perfect square. Square root that first term and that last term. So square root 4x squared will give you 2x. And if you square root 49, that'll give you 7. And so we can write that as 2x plus 7 squared. Okay, so now again, we can look at quadratics in the form a squared x squared plus bx plus c. These are commonly known as simple trinomials. There's a few ways to look at this. So here we have x squared plus 3x minus 40. So here we can need two numbers that will multiply to equal to negative 40. And the same two numbers need to add up to equal to 3. Or in this case would be the b value. So here, these two numbers would be 8 and negative 5, and 8 and negative 5. So 8 times negative 5 will give us negative 40, and 8 plus negative 5 will give us 3. And so here we can write them as x plus 8, x minus 5. Okay. Here we again have x to the power 4 minus 6x squared plus 9. Here we can actually recognize that this is a perfect square trinomial. As if we square root that first term of x to the power 4, we'll get x squared. And if we square root that last term of positive 9, we'll get value of 3. And so here, our answer will be x squared minus 3 squared. And then finally, when we look at quadratics in the form ax squared plus bx plus c, these are commonly known as complex trinomials because the a value is not 1. And so there's a couple ways to solve this. Here, we'll use the process of decomposition. But there's also the crisscross method, which we'll look at in another video. And we also have the slide and divide method. All of these are possible ways to solve for quadratics in the form ax squared plus bx plus c. Here today we'll look at decomposition. So when we look at decomposition, again, same idea. We have two numbers that multiply to a times c, which will be -6, and two numbers that add up to equal to 5. In this situation, will be 6 and -1, and 6 and -1. And so we write this out, or we rewrite the equation as 3x squared. We split the 5x into the two factors we just found. So plus 6x minus 1 minus 1x minus 2. And from here, we're going to take out a common factor from the first two terms and from the last two terms. So here we take out 3x. We're left with x plus 2. And if we take out a -1, we are left with x plus 2. We see that now we can take out the common factor as well of x plus 2. So we have x plus 2, and what we're left over with is 3x minus 1. And so let's look at this last question here. Same kind of concept. Again, we need two numbers that are going to multiply to equal to -24. And how we found that is we're going to common factor first. So if we common factor the 2, we're left with 6x squared minus 5x minus 4. So we have two numbers that multiply to -24 and two numbers that add up to equal to -5. And those two numbers are -8 and +3 and -8 and +3. So here we can split the middle up. So we have 6x squared plus 3x minus 8x minus 4 is equal to 2 bracket 3x, which will factor out the 3x from the first two terms, leave us with 2x plus 1. We factor out -4, we'll be left with 2x plus 1. So our final answer here is 2 bracket 2x plus 1, 3x minus 4.